Hi, welcome to season 2 of QuBites, your bite-sized pieces of quantum computing. My name is Rene from Valorem Reply, and today we're going to talk about quantum machine learning with a focus on natural language processing. And for this, I'm very honored to have a special expert guest today, Alessandro Farace. Ciao, Alessandro, and welcome to the show. How are you today?
Ciao, Rene. I'm happy to be here, fine, and looking forward to our chat about quantum NLP.
Awesome. So before we dive a little bit more into these topics, can you tell us a little bit about yourself and your background as it relates to quantum computing?
Yes, sure. So I've been working now for more than 2 years in machine learning reply as a data science consulting. I've been mostly doing projects on natural language processing, so dealing with text documents and natural language. But my background comes actually from physics. So I did a PhD in Pisa on quantum optics, quantum information theory. And then I did 3 years of research as a postdoctoral researcher on developing algorithms for quantum simulations. So a lot of topics related to quantum computing. And now in Reply, we have a quantum computing community of practice where we look at business applications of quantum technologies and quantum algorithms.
All right. Awesome. Well, again, another PhD here in the show, but please, we are going to talk about so that also people that don't have a PhD like me can understand it. And that's the goal, right? So let's talk about natural language processing or NLP. And first of all, can you explain what is NLP all about? Does NLP actually include?
Yes, so NLP is a field of linguistic, computer science, artificial intelligence, with the goal of processing and analyzing natural language. So it's about making a machine understand the content of speeches and documents and being able to process information that is not written in a structured way. So text documents have a lot of variability, a lot of nuances related to language, and it can be in many different languages. And we want to teach a machine how to do this. So there are several tasks that fall under the NLP topic, from speech recognition, so understanding spoken language, to generating machine text, to translation from one language to the other, to more sophisticated topics like extracting information out of documents, classifying documents based on their content, sentiment analysis. So we want to understand if a review or a message is a negative sentiment or a positive sentiment. And also a very important topic is question answering. So finding out the answer to a question from a corpus of documents. This can be also used for fact checking or for chatbots. Uh, it's really a topic that has many applications even in industry. And
Right.
this
So it
topic
also
also,
includes like conversational AI systems, right?
yes, exactly. And an important thing is that this topic saw a lot of growth in the recent years, thanks to a lot of data available on the web. So on the web, you find a lot of written documents and text documents, text data, and also a lot of progress on the machine learning side. So we now have really powerful models that can understand the meaning of words, the meaning of documents, and that can help us solve all of these tasks.
Gotcha. Gotcha. And yeah, I mean, like you were saying, there's an immense uptake thanks to all the open research that is ongoing, but also all the immense amount of data and the processing power at our hands available these days, right? And yeah, it's super impressive what you see already with conversational AI systems that can really, you might not actually notice that you're talking to a machine, right? And this is the level we are really approaching here. And so now, coming to the quantum computing world, and how is actually quantum computing providing benefits in this field of NLP, natural language processing, and what is the state of the art and the latest state of the art in that field?
Yes, so maybe let me start by giving a few words on the state of the art of classical NLP, just to set the context. So there we have now very powerful models that are able to understand the meaning of words. So they learn the meaning of words by looking at the context, using the key idea that similar words will appear in similar contexts, so in similar sentences or appearing close to other similar words. So now these models are very good at capturing synonyms and understanding, okay, this word really means this has this semantic meaning. What is harder for these models is to understand the meaning of sentences and longer pieces of text, because a word will appear several times in many documents. We have a dictionary of words. We can understand the meaning of words, but like each sentence will appear more or less once. It's very hard to have the sentence repeated. Sentences are much more variable, so it's harder to capture the meaning of sentences. There were recently very huge progresses with huge models. Like one example is the GPT-3 model. If people heard about it, it was on the news recently. And this model requires a lot of parameters, a lot of training data. It has been trained for a lot of time on very powerful resources. And it started giving promising results also on this side. So basically, these models have to learn all the structure and the grammar that we humans use to understand a text from a lot of data. Now, on the quantum NLP side, people recently introduced some new language models from the linguistic side, which use grammar as a rule. So they don't learn it from the data, but they enforce it as a rule. And this is computationally expensive classically. So a classical machine will need too much resources to do that. It's almost impossible if you want to analyze long documents. But it turns out that these kind of mathematical rules that describe grammar have a natural formulation as quantum circuits. So with a quantum computer, we can add the meaning of words, that is what the models can already do very well now, with the grammar part. And this should help in boosting all the tasks that require understanding the meaning of sentences, because now the meaning of a sentence will be composed from the meaning of words using these extra grammatic rules that we impose on the sentence. And on top of that, there are also some nice features like there are words that have several meanings in different contexts. We can make an example. For example, bank could be the building where you go, could be a river bank, could be a place where you sit. And classically, you just give it one meaning, or it's harder to disambiguate the meaning. With concepts like superposition and other quantum properties, you can naturally encode this variability of meaning for a single word. So you get a lot of new ingredients that are very hard to do classically, which could boost your learning capabilities. And what is also nice is that we have now a formulation of this quantum model that works on noisy intermediate quantum devices. These are the state-of-the-art hardware that we are available now. And so people already did the first experiments on limited vocabulary or on small training data, but it's not something that will require a huge leap in technology, something that we can start seeing now. And there are also some initial results showing that you can have several types of speed up in tasks related to NLP, like understanding sentence similarity and word similarity. And this is really one of the key tools that you need for all tasks like question answering and classification and topic modeling. So it's really a promising field. Also, not just because it can do something faster or better, but it can do something new. So it could really have some potential in boosting our capabilities to do natural language processing.
Well, that makes a lot of sense, and especially it clicked a lot for me when you said like, "Hey, one word might have different meanings, and this can be expressed with a qubit in superposition because it can have multiple values at the same time, right? Or can hold multiple information at the same time, which is it just fits naturally, right, into natural language processing with quantum computing. Well, that is amazing. And what is Reply actually doing in these areas? And can you share some examples?
Yeah, so in Reply, in machine learning Reply, we actually have done several projects in natural language processing related topics. So a lot, for example, in customer management for companies that deal with a lot of customer messages, and they want to, for example, understand the topics of the conversations. We did a lot in terms of classification of customer requests. Then you can also extract automatically the information that you need to um, to process these requests. For example, a customer writes you, I would like to change my contract to this and this, or I'm moving to a new apartment, please change my address. These are a lot of messages that you would like to process automatically. So you need to understand what does the customer want, and what are the information hidden in the text that you need to somehow act on this request. Also, sentiment analysis, it's a very big topic, like understanding if the customer is complaining about something and why, and how can you react to this before the customer gets really angry. And also, NLP plays a huge role in like finance and insurance, where like banks and insurance companies are interested in also getting information from news from external sources about new risk factors, new trends, understanding what is out there that could help them better shape their risk profile and deal with their investments more carefully. So a lot of also discovering new trends, discovering new relevant information from the news. This is something that has a lot of potential for all companies that would like to leverage this kind of information that is available there. On the quantum
Right.
side, we are starting now some first experiments on these quantum NLP topics. Of course, this is a very experimental and researchy field at the moment, but we are trying to do our first implementations and see and understand what can be done today with available hardware. So how far can we push it, and what could be some industry applications of these early algorithms that we can write and use.
Awesome. Awesome. Well, that is exciting for sure. And like you said, it's bleeding edge, right? We're really at the level of research and helping to progress that forward. So that is amazing. Unfortunately, we're already at the end of the show. We could talk for many more hours for sure. But anyway, thank you so much, Alessandro, for joining us today and sharing your insights with all of us. That is very much appreciated.
Yes, I'm happy to have been here. It was a nice chat with you. I hope people could learn something interesting about quantum computing. I personally find this very exciting. So thanks for the chat.
Absolutely. And thanks everyone for joining us today for another episode of QuBites, your bite sized pieces of quantum computing. Watch our blog, follow our social media channels to hear all about the next episodes, and of course, also to find the previous episodes, which you can watch anytime, right? Take care, be safe, and see you soon. Bye bye.
Bye bye.